Hello students, welcome back to my YouTube channel Chemistry Pocket. Myself Srilata. In this today video, I am going to explain a simple trick for the calculation of hybridization. Now let's see the formula. So hybridization equals to number of atoms attached to the central atom plus lone pair of electrons on that atom. So this is the formula now I am going to use for the calculation of hybridization. Okay, number of atoms attached to central atom plus lone pair of electrons on that atom. So after the calculation, if we get 2 means it represents sp hybridization. If the answer is 3 means it represents sp2 hybridization, and 4 means sp3, 5 means sp3d, 6 means sp3d2, 7 means sp3d3 is there, and 8 and 9 also there. So 8 means sp3d4 and 9 means sp3d4. So up to this is enough. So that's why I'm not writing those two. Okay. Now let's see the examples. Okay. First of all, I am taking the example as ammonia, NH3. Now I am calculating the hybridization of nitrogen in ammonia molecule. So ammonia is belongs to group 15th element, and its valence shell electronic configuration is NH2NP3. It is nothing but totally 5 electrons are there in the valence shell of nitrogen. Now let us see here, 3 electrons are utilized for the bond formation. It is nothing but minus 3 electrons. So remaining 2 electrons are there. 2 electrons are nothing but one lone pair. Now let us calculate the hybridization. So hybridization equals to number of atoms attached to the central atom. So how many number of atoms are attached here? 3 plus lone pair of electrons. How many number of lone pair of electrons are there here? 1. So 1. It is nothing but 4. 4 is nothing but what is the hybridization? sp3. Yes, very good. sp3 hybridization. So it is about the nitrogen. So in ammonia, the nitrogen hybridization is sp3 hybridization. Now let us take the one more example as CH4, methane. So example is methane. So in this methane, carbon belongs to group 14th element, and its valence shell electronic configuration is NH2NP2. It contains 4 valence electrons and it formed 4 bonds. So 4 electrons are involved in the 4 bonds. So there is no lone pair of electrons. So it is nothing but 0 lone pair electrons. So now hybridization equals to, so number of atoms are attached is 4 and the number of lone pairs are 0. It is nothing but 4. It is nothing but again in methane molecule the carbon hybridization is also sp3. So in the same way we can calculate the hybridization of anyone, that means beryllium chloride. Write for beryllium chloride, BeCl2. So in this beryllium chloride, so boron belongs to second group element and its electronic configuration is NH2. NH2 is nothing but it contains 2 electrons in the valence shell, and already it formed 2 bonds with the 2 chlorine atoms. So lone pair of electrons are 0. So 0 lone pairs. Okay. Now let us calculate the hybridization here. Hybridization equals to number of atoms are attached is 2 and the lone pairs are 2. Sorry, lone pairs are 0. So the answer is 2. 2 is nothing but what is hybridization? sp hybridization. Yes, very good. sp hybridization. So this is about the simple molecules. So in these 3 examples, in ammonia, carbon, methane and also beryllium chloride, we saw the simple molecules only. Now let us take the heavy molecules or heavy compounds. Suppose take the example as, for the next example is SF6. Okay, SF6. So in this SF6, sulfur belongs to 6th group and its electronic configuration is NH2NP4. Not the electronic configuration, valence shell electronic configuration is NH2NP4. It is nothing but it has 6 valence electrons. 6 electrons. Already 6 bonds are formed. 6 electrons, 6 bonds. So, lone pair of electrons are 0. So, 0 lone pairs. 0 lone pairs. It is nothing but hybridization equals to number of atoms are attached is 6 and the lone pairs is 0. It is nothing but 6. 6 is nothing but sp3d2. sp3d2. Okay. Next, let us take IF7. IF7. So, in this IF7, so iodine belongs to 17th group. 17th group. Sorry, here sulfur belongs to 16th group. Okay. Sulfur belongs to 16th. And here iodine belongs to 17th group. And its valence shell electronic configuration is NH2NP5. It is nothing but totally valence, 7 valence electrons are there, that and 7 bonds are there. So there is no lone pairs, 0 lone pairs. Next, hybridization equals to 7 minus 0. 7 atoms are present and lone pairs are 0. 7 minus 0 is nothing but 7. 7 is nothing but sp3d3. sp3d3. So it is about the heavy compounds. Next, let us see. Suppose if any double bonds are there, how we can calculate the hybridization means? So we can follow the same rule. Okay. Suppose take XeO3. XeO3. So in this, xenon belongs to group 18th element and its valence shell electronic configuration is NH2NP6. NH2NP6 is nothing but total number of electrons are 8 electrons. That means valence electrons are 8. So in that 8, so here 3 bonds are present with 3 oxygen atoms. Here each oxygen atom is forming 2 bonds with xenon. So that's why 3 2s are 6. That means 6 electrons are utilized. It is nothing but remaining are 2 electrons. 2 electrons is nothing but 1 lone pair. So lone pair of electrons is equals to 1. Now let us calculate hybridization. So hybridization equals to, so number of atoms are attached is 3 and the lone pairs are 1. So it is nothing but 4. 4 is nothing but sp3. 4 is nothing but sp3. So next one more example is XeOF4. XeOF4. So here also xenon, same group number 18th and valence electrons are 8. Okay. In 8 electrons, so here oxygen is, so xenon contains 8 electrons and fluorine is forming 4 bonds, that is nothing but 4 electrons, and oxygen is forming 1 bond. 1 bond is nothing but 2 electrons. For oxygen, that means oxygen is forming 2 bonds with xenon. One is sigma bond and another one is a pi bond. So that's why 4 plus 2, 6 electrons are utilized. 6 electrons are utilized means only 2 electrons are remains. 2 electrons is nothing but 1 lone pair. Okay. Now hybridization equals to, how many number of atoms are attached to the xenon? 4 plus 1, 5. 5 plus lone pairs are 1. It is nothing but 6. 6 is nothing but sp3d2. sp3d2. So it is the, so in this way we can calculate hybridization if a compound contains double bonds. Okay. Suppose take, if a compound contains charge, how we can calculate it? By using the same formula. Here also, for this type of compounds also we can use the same formula. Suppose take H3O plus. H3O plus. So in this one, suppose oxygen is a group 16th element and its electronic configuration, valence shell electronic configuration or general electronic configuration is NH2NP4. NH2NP4. That means it contains 6 electrons in their valence shell, and that 6 electrons, and here how many hydrogens are there? 3 hydrogens. Okay. 3 hydrogens is nothing but minus 3 electrons. It is 3 electrons are the remains, and positive charge is there. It is nothing but again minus 1 electron. It is nothing but only 2 electrons are there. 2 electrons. 2 electrons is nothing but 1 lone pair. 1 lone pair. So hybridization equals to, how many number of atoms are attached here? 3. 3 plus how many number of lone pairs are there? 1 equals to 4. 4 is nothing but, what is hybridization here? sp3. sp3. Next, let us see the hybridization of NH4 plus. NH4 plus. Okay. So in this one, nitrogen belongs to 15th group. So NH2 NP3. It is nothing but 5 electrons. So already 1 electron is not there because of positive charge. 1 electron is not there. So 4 electrons minus 1 electron. It is nothing but 4 electrons. So how many number of bonds are there here? So bonded pair of electrons are 4. It is nothing but 0. Lone pair of electrons are 0 in this one. Okay, lone pair of electrons are 0. So hybridization equals to number of atoms attached is 4 plus 0 equals to 4. 4 is nothing but sp3. Next, one more example is SO4 minus 2. SO4 minus 2. So in this one, sulfur is 16th group element and its electronic configuration is NH2NP4. NH2NP4. And here also sulfur contains 6 electrons. Okay. And because of minus charge, it gains 2 electrons. It is nothing but 8 electrons are there. In that 8 electrons, so 4 oxygen atoms are there. 4 oxygen atoms are utilized these 8 electrons because each oxygen atom is forming a sigma bond and also pi bonds with the central atom. So that's why 8 electrons are utilized. It is nothing but 0. It is nothing but lone pair of electrons are 0. So hybridization equals to number of atoms are attached is 4 plus lone pair of electrons are 0. It is nothing but 4. So hybridization is sp3. Okay. So in this way we can calculate the hybridization of any element in any compound. We can calculate the hybridization easily. I think this is very easy trick for the finding of an hybridization. So different books contains different formulas. I think it is one of the best trick to find the hybridization. Now let us see just a recap of this class. Okay, so the hybridization formula is number of atoms attached to the central atom plus lone pair of electrons on that atom. Okay, if the answer is, that means by knowing these two only we can calculate the hybridization. Okay, without knowing any atomic number or the complete electronic configuration of an element also we can calculate by using this trick. So if the answer is 2 means sp, 3 means sp2, 4 means sp3, 5 sp3d, 6 sp3d2 and 7 sp3d3 hybridization. Suppose I am taking the examples as NH3, CH4 and BeCl2 as a simple molecules. Okay, simple compounds. And here in NH3, nitrogen contains 1 lone pair of electron and 3 atoms are attached to the nitrogen. 3 hydrogen atoms are attached. So hybridization equals to 3 plus 1 equals to 4. 4 is nothing but sp3 hybridization. And CH4 number of lone pair electrons is 0. And here number of atoms attached is 4 equals to 4. 4 plus 0 is nothing but 4. So hybridization is sp3. So how we are getting 0 lone pair of electrons means here carbon belongs to group 14th element and its valence shell electronic configuration is NH2NP2. That means total number of electrons present in the valence shell of carbon atom is 4. That 4 electrons are utilized by the 4 hydrogen atoms in the bond formation. So that's why the lone pair of electrons are 0. Next, for BeCl2 also number of lone pair of electrons are 0. So the answer is 2 because only 2 atoms are attached to the beryllium. So 2 means sp hybridization. Next, now I am going for the heavier compounds. So SF6 and IF7. So in this SF6, sulfur belongs to 16th group and it contains 6 electrons in the valence shell, and the lone pair of electrons are 0 because 6 electrons are utilized by the 6 fluorine atoms for the bond formation and it is forming 6 sigma bonds with 6 fluorine atoms. So hybridization equals to, because of presence of 6 fluorine atoms we are writing 6 plus and 0 lone pair of electrons, so plus 0 equals to 6. It is nothing but sp3d2 hybridization. In the same way we can calculate IF7 also. Okay. Next one is, if any compound contains double bonds, means how we can calculate, means same formula. So in xenon XeO3, so the number of lone pair of electrons is 1. So hybridization equals to 3 plus 1 equals to 4. And in XeOF4 also the number of lone pairs is 1. So the answer is 6. 6 is nothing but sp3d2 hybridization. sp3d2 hybridization. And next one is, if any ion is given, how we can calculate? Means say, if positive charge is there, so do the minus of electrons. If negative charge is there, do the addition of electrons. So my positive charge indicates the loss of electrons, and negative charge indicates gain of electrons. So in H3O plus, oxygen contains positive charge. It is nothing but in the valence shell of oxygen it contains 6 electrons. And one positive charge is there means only 5 electrons are present. So here 6 electrons are there in the valence shell of oxygen. So 3 electrons are utilized for the bond formation with 3 hydrogen atoms. And also here one positive charge is there. That is nothing but one. We have to do the subtraction of 1 electron from the valence shell electrons. So by doing the subtraction we are getting 2 electrons. 2 electrons is 2 electrons. 2 electrons is nothing but one lone pair is present. So 3 plus 1. 3 atoms are attached and 1 lone pair is present. 3 plus 1 equals to 4. It is nothing but sp3 hybridization. Next, in NH4 also, in NH4 plus also, 0 lone pair of electrons. So answer is for sp3 hybridization. And in SO4 minus 2 also, 0 lone pair electrons. And answer is for, it is nothing but sp3 hybridization. Okay. Okay students, I hope you understood this today's topic. So it is very, very simple and easy trick. Okay. Thanks for watching and please subscribe my channel Chemistry Pocket.